Have you ever wondered what it would be like to journey to a star system that's completely different from our own? Imagine leaving Earth behind, traveling across the vast stretches of space, and reaching a place where two stars orbit each other in a cosmic dance. A binary star system, with all its mysteries, dangers, and incredible beauty. Sounds like science fiction, right? Well, what if I told you that by the year 2250, it might just be possible to do exactly that? Yeah, you heard that right. By the middle of the 23rd century, humanity has made some huge leaps in technology. We're talking about ships capable of faster-than-light travel, AI companions that are practically family, and human bodies that are stronger and more resilient than ever. And we're not just talking about staying within the solar system. No, by 2250, we're venturing into deep space, exploring alien worlds, and even visiting binary star systems. So what's the deal with binary stars? Why are they so special? And why are we even thinking about sending humans to explore them? Well, for one, these systems are often packed with mysteries. Two stars orbiting each other in a tight gravitational bond. Planets caught in their shared gravity could be in just the right zone to support life. But let's be real. It's not all sunshine and rainbows out there. There are dangers in the unknown, and a journey like this comes with some serious risks. On this adventure, we're going to join a crew of brave individuals, each one with a specific job to make this mission a success. You'll get to meet them, learn what they're doing, and see the kind of tech they'll be using. And trust me, we'll need all the help we can get as we explore a binary system that's light years away from home. But before we jump to the action, let's talk about how we got here. How did humanity go from dreaming about space travel to actually making it a reality? And what exactly is the technology that makes this kind of interstellar journey possible? Because, spoiler alert, it's not just rockets anymore. We've come a long way since the days of Apollo missions and space shuttles. Fast forward a few hundred years, and we've mastered things like fusion propulsion, which gives us the ability to travel at incredible speeds without running out of fuel. And that's just the start. By 2250, we have ships that can bend time and space, cutting down travel times from decades to just a few years. Pretty mind-blowing, right? But of course, it's not all about the tech. We're talking about human beings here, people who have to live and work together in space for extended periods. So we'll also take a look at the crew of this particular mission, the team that's going to make it all happen. They've been selected for their expertise, but they're also there to show us what it means to be a part of humanity's next giant leap into the stars. As we get ready to set off, I want you to imagine something with me. Picture yourself sitting in a spaceship, looking out at the endless expanse of space, and knowing that the next few years of your life will be spent traveling to a star system light years away. What's going through your mind? Are you excited, nervous, or just in awe of how far we've come? Maybe a bit of all three? All right, it's time to leave Earth behind. The countdown has begun, and we're about to take that first giant leap toward the stars. But before we get there, let's take a deeper look at what a binary star system actually is and why it's so intriguing for scientists and explorers alike. Because trust me, this is where the real adventure begins. Now, before we actually leave Earth's atmosphere and head into the stars, let's take a moment to talk about how we got here. How is it that, by the year 2250, we're able to send human crews on interstellar missions to binary star systems? The answer lies in the incredible progress we've made in space travel technology. Let's go back for a second. Remember those old rockets from the 20th century? Yeah, we've come a long way since then. Back in the early days of space travel, reaching outer space was a monumental challenge. It was all about brute force, firing rockets into the sky, relying on chemical propulsion to break free from Earth's gravity. But as we moved into the 21st century, new technologies started emerging. Think about the advent of ion engines, which used electric propulsion to generate thrust more efficiently, or advancements in nuclear fusion, which gave us much more power for a lot less fuel. But the real game changer? It's fusion-powered propulsion. And no, we're not talking about small, experimental prototypes anymore. By 2250, humanity has figured out how to use fusion energy for large-scale space travel. Basically, we're harnessing the power of the stars to fuel our ships. The energy generated by fusing atoms is clean, incredibly efficient, and can give spacecraft the thrust they need to travel vast distances without constantly refueling. And if you're thinking, but isn't the distance between stars ridiculously far? Well, yeah, it is. But with these kinds of propulsion systems, we've managed to drastically reduce travel time. Instead of taking thousands of years to reach a distant star, we can now make it in just a few decades. A journey that would have been out of the question in the past is now a matter of planning and preparation. Now, that doesn't mean space travel is a walk in the park. We're still dealing with all kinds of challenges. For one, cosmic radiation is a huge concern. Space is filled with high-energy particles that could do some serious damage to both our technology and our bodies. So how do we deal with that? Well, by 2250, we've developed advanced shielding materials capable of protecting us from harmful radiation, keeping the crew safe during the long haul. And it's not just about the tech, it's about the people who make it all happen. By now, we've learned that long-term space travel requires more than just a strong ship and a fast engine. It's about ensuring the crew can handle months or even years in the vast emptiness of space. That means advanced life support systems, artificial gravity, and even psychological care to prevent isolation-induced stress from getting the best of our astronauts. By 2250, humans are more resilient than ever. With genetic engineering, we've enhanced our physical and mental abilities. Space travel no longer just requires a willingness to venture into the unknown. It takes individuals who have been physically optimized for the challenges of long-term spaceflight. From enhanced bone density to better resistance to radiation, humans are adapting to become true spacefarers. And let's not forget about the AI. The artificial intelligence systems on board these ships are incredibly advanced, providing real-time support for everything from navigation to medical emergencies. They're not just tools, they're companions, capable of learning from the crew, making decisions in high-stress situations, and even offering moral support when the going gets tough. So, with all these advancements in tech and human ability, it's no wonder that we're now able to send crews on long, deep space missions. But before we get ahead of ourselves, let's dive a bit deeper into the specifics of the binary star system we're headed to. What makes this system so special? Why are scientists and explorers so eager to check it out? Well, to answer that, we need to understand a bit about what a binary star system is. And let me tell you, it's not your typical star system. These systems are made up of two stars, orbiting each other, instead of just one like our Sun. The gravitational dance between these stars can create some truly fascinating possibilities for planets and moons in the system. Planets in the right spot could have the right conditions for life, which is exactly what we're hoping to find. All right, so let's talk about binary star systems. What exactly are they, and why are we so fascinated by them? If you've ever looked up at the night sky, you probably know that most stars we see are solo, like our Sun. But here's the thing, not all stars go solo. A lot of them come in pairs, or even more, forming what's called a binary or multiple star system. And when you're talking about space exploration, binary systems offer something really unique. So what exactly is a binary star system? Simple. It's a system where two stars orbit around a common center of mass. These stars are bound together by gravity, and they dance around each other in a never-ending gravitational pull. One might be a massive, glowing giant, while the other could be a dimmer, cooler star, or even a white dwarf. And this interplay creates some interesting possibilities for the planets that might orbit these stars. Now, you might be wondering, why are we so interested in exploring these systems? Well, binary stars aren't just a cool cosmic phenomenon. They're also prime real estate for planets that might be habitable. Think about it. With two stars, there are multiple habitable zones. Normally, a planet has to be in the Goldilocks zone. Not too hot, not too cold, around a single star to support life. But in a binary system, the habitable zone is much larger, and planets can exist in different positions around both stars. Some planets might orbit both stars, or they could orbit just one, while the other star affects their climate and atmosphere. It's a dynamic, sometimes unpredictable environment, but it's also one that could offer a wide range of conditions for life. There's even a possibility that these systems could have more stable orbits for life than planets in a single star system. But let's not get ahead of ourselves. Just because there's potential for life doesn't mean we'll find it. Binary stars bring their own set of challenges, too. The gravitational pull between the two stars can cause some strange things to happen. For instance, the orbits of planets can get a little chaotic, which might make conditions on those planets harder to predict. And then there's the radiation. Two stars can be much more intense in terms of solar radiation, which means any planet that's in the habitable zone has to have some serious protection, like a thick atmosphere, to shield life from the harmful rays. Also, the stars in these systems aren't always stable. Sometimes one of them might burn through its fuel faster than the other, going supernova or collapsing into a black hole. If that happens, it could totally disrupt the entire system, including the planets and any potential life that might be there. It's a delicate balance. A binary system can offer a unique environment for planets, but it can also bring a lot of unpredictability. So, now that we know a bit about the general makeup of binary star systems, let's talk about the specific system we're heading to. This system we're about to explore has a fascinating combination of stars that makes it a prime target for our journey. One of the stars is a massive, young star, burning brightly with incredible energy, while the other is a cooler, older star. Together, they create an interesting environment where the planets are caught in a gravitational tug-of-war, making their orbits and conditions extremely fascinating. And what about planets? Well, this system has a few of them, and the interesting thing is that some of these planets are in the so-called sweet spot, where conditions could be just right for life to form. The habitable zone here is much larger than what we'd find around a single star, and there are a few planets that seem to fit the bill. Some of them might have oceans, atmospheres, and even the right chemical conditions for life as we know it. But even with all the possibilities, we can't just assume it's a paradise waiting to be explored. As much as these planets look promising, we're still talking about an environment that's radically different from Earth. These planets might have extreme weather patterns, heavy radiation, and other factors that we'll need to understand before we can make any claims about life being there. So, while the binary star system we're heading to has a lot of potential, it's not without its dangers. But that's what makes exploring these kinds of systems so thrilling. There's always the possibility of unexpected discoveries, whether that's a hidden life form or a strange anomaly we've never seen before. Okay, now that we've got a sense of what we're heading toward, a binary star system with planets that could support life, it's time to talk about what goes into actually getting there. You can't just hop in a spaceship and blast off. There's a whole lot of planning, prepping, and making sure everything is in tip-top shape before you even leave the ground. First things first, the ship. This isn't your typical space shuttle. No, this is a highly advanced interstellar vessel designed to travel across light years of space. It's equipped with everything needed for a long, long journey. Imagine a combination of a futuristic cruise liner and a high-tech research facility, all rolled into one. It's not just a mode of transportation. It's a mobile home, a laboratory, a control center, and a lifeline, all wrapped up in one sleek, metallic package. The ship itself is powered by that next-gen fusion propulsion we talked about earlier. So, instead of relying on chemical fuel that only lasts for so long, this ship uses fusion to keep everything running, giving it the ability to travel vast distances with minimal refueling. And when you're heading into deep space, you want a ship that can handle the unexpected, from cosmic radiation to system malfunctions. This ship has multiple layers of backup systems to keep things running smoothly. And it's not just the engines. There's everything else the crew will need. Think about the crew quarters. Even though this journey is going to take several years, the crew isn't going to be living in cramped, uncomfortable spaces. Nope, these quarters are designed to feel as close to home as possible. We're talking private rooms, exercise areas, even virtual reality lounges for when they need to unwind. Space is big, but a journey like this can feel incredibly isolating, so the goal is to keep everyone as comfortable and mentally healthy as possible. And of course, we can't forget about health. A trip to a binary star system isn't just about the technology, it's about the people on board, too. The crew's physical and mental well-being is crucial. They'll be on this ship for years, so there's a whole medical team on board, equipped with state-of-the-art technology to handle everything from routine checkups to more serious emergencies. There's even a full gym where they can work out in zero gravity, making sure they don't lose muscle mass or bone density along the way. Now, here's where things get interesting. The real key to a successful mission isn't just having the best ship or the best technology. It's having the best crew. In fact, this crew is made up of some of the best and brightest people humanity has to offer. You've got experts from all walks of life: astronauts, engineers, biologists, doctors, and even AI specialists. Each one plays a crucial role in ensuring that everything goes as planned. For example, let's meet the captain. She's a seasoned space veteran with decades of experience leading teams on deep space missions. She's calm under pressure, and she's been trained to handle just about anything that comes her way. Then there's the chief engineer, the person who's going to be making sure that the fusion propulsion system runs smoothly and that all the ship's systems are working as they should. She's spent years learning the ins and outs of spacecraft engineering, and she knows that when it comes to a mission like this, there's no room for error. And then we've got the biologists and environmental scientists who will be studying the planets in the binary star system, analyzing atmospheres and looking for signs of life. They're the ones who are going to make sure that the conditions on these planets are just right or not, and they'll help determine if any of them could support human colonization. These scientists are critical because their discoveries will guide the next phases of humanity's exploration of these systems. On top of all that, there's the AI specialist, whose job is to ensure that the ship's AI is functioning perfectly. This isn't your average computer system. It's a highly advanced AI that interacts with the crew, learns from them, and even helps make real-time decisions during crises. The AI will be able to diagnose issues, suggest solutions, and handle everything from navigation to life support. It's like having an extra, incredibly smart crew member on board 24/7. Together, these experts make up a team that's ready for just about anything. But let's not forget about the psychological aspect of this journey. Imagine being in space for years at a time, far from home, with no real contact from Earth. The isolation can take its toll. That's why the crew will have regular mental health check-ins, communication with Earth via light-speed messages, and plenty of ways to stay connected to each other and to their mission. So with the crew prepped, the ship ready, and the technology humming along, it's almost time to say goodbye to Earth. But before we do, we've got one last thing to do. make sure the ship is fully stocked for the long journey ahead. We're talking food, water, oxygen, and all the supplies needed to keep the crew alive and well as they venture further than any human has before. All right, the time has finally come. After years of planning, preparing, and getting everything ready, it's time to leave Earth behind and start our journey to the binary star system. I know it sounds like something out of a science fiction movie, but this is the real deal. The engines are primed, the crew is suited up, and everything is ready for takeoff. But before we blast off, there's one thing I want you to remember. This is no ordinary journey. This is humanity taking a giant leap into the unknown. As the countdown reaches its final moments, there's a mix of emotions, excitement, nervousness, even a little bit of fear. And honestly, that's completely normal. Sure, we've got the best tech, the smartest people, and the most advanced ship on the planet, but there's always that unknown factor when you're venturing into deep space. Anything could happen out there. But at this point, the crew has done their homework. They've trained for this, over and over again. They've gone through simulations, emergency drills, and every possible scenario you can imagine. And now, it's time to execute. The engines fire up, and the ship begins its slow ascent off the ground. At first, it feels like any other rocket launch, but once we break through the atmosphere, things get a lot quieter. Space, after all, is incredibly, well, silent. As the ship rises higher, the view changes. Below us, Earth looks like a small marble, surrounded by nothing but blackness. But up here, the whole experience feels surreal. There's something about leaving your home planet that shifts your perspective, like you're on the edge of something huge, something bigger than you can even wrap your head around. Once we're in space, it's all systems go. The crew settles into their roles, keeping everything running smoothly. The captain takes her place at the helm, keeping an eye on the trajectory, while the engineers monitor the propulsion system. The biologists start prepping their equipment for the planetary scans, and the AI specialist ensures everything is running as it should. Even though we're out of Earth's atmosphere, we've still got a long way to go. This is where the real journey begins. The crew knows they've got years ahead of them, so now it's about settling into the routine. Day-to-day life in space isn't like on Earth. There are no sunrises to mark the passing of time, no changing seasons. It's a never-ending stretch of blackness, punctuated by the occasional flicker of starlight or a passing asteroid. As the first few days go by, the crew starts to find their rhythm. There's a lot of work to do, but there's also time to relax, to chat, to look out the window at the stars. And while that might sound peaceful, it's not all smooth sailing. Space is unpredictable. Even though we've got the best tech and the brightest minds, there are still challenges to face. Things can go wrong, systems can fail, and the isolation can start to weigh on you. And that's why the crew has regular check-ins, not just with the ship's systems, but with each other. They've got each other's backs, and they've been trained to handle the mental and emotional side of long-term space travel. Even in the most isolated environment, it's the bonds between people that keep things moving forward. As the days blend into weeks, the crew knows they've only just started this journey. The vast distance between Earth and the binary star system means they've got years of travel ahead of them. But that's part of the excitement. This isn't just a quick trip. This is about exploring the unknown, pushing the boundaries of what we know, and discovering things that could change the future of humanity forever. And every day, as they continue their journey, they know that what they're doing is a part of something bigger than themselves. This mission is about discovery, about answering questions we've had for centuries. Is there life out there? Could we live on another planet? And what are the mysteries of these binary star systems that have been calling to us from across the galaxy? All right, we've made it out of Earth's atmosphere, and we're cruising through space. But let's be real. This isn't all smooth sailing. Once you get beyond the comforts of our home planet, space can be incredibly unforgiving. And when you're on a mission this big, traveling light years to explore a binary star system, you quickly realize that space throws a lot of challenges your way. First off, let's talk about navigation. Space isn't just a giant empty vacuum. There are all kinds of obstacles out here, from rogue asteroids to cosmic dust clouds. In fact, the ship has to constantly adjust its course to avoid potential collisions. These things move fast, and even a tiny object can cause a catastrophic impact if the ship doesn't dodge it in time. And speaking of space dust, that's another hurdle. We're talking about tiny particles that are almost invisible to the naked eye, but they're floating around at insanely high speeds. A collision with even a small speck of space dust can cause significant damage to the ship's outer hull. That's why the engineers have designed the ship to be super resilient, with reinforced plating and shields that can absorb most of the impact. Then there's the issue of radiation. Space is filled with all kinds of high-energy particles, and these rays can be harmful to both the ship's electronics and the crew's health. Even though we've got state-of-the-art shielding protecting us from most of it, there's still a risk. And as we get deeper into space, away from Earth's magnetic field, that radiation gets stronger. So the crew is constantly monitoring the levels, making sure the shields are up to par. And don't get me started on the loneliness. Out here, it's just you and the stars. Sure, the crew is on board and they've got each other, but nothing really prepares you for the isolation of deep space. There are no familiar faces, no bustling cities, no connection to the world you once knew. For months or even years, you're completely cut off from Earth. The communication delay is massive. What you say today won't get to Earth until months later, and when a message comes back, it's a long wait before you hear a reply. It can start to feel like you're a tiny speck in a vast, indifferent universe. That's where the psychological side of space travel becomes critical. The crew is trained to deal with isolation and the mental strain of being so far from home. They have regular check-ins with the ship's psychologist, and there's a focus on maintaining strong team dynamics. Isolation can lead to stress, anxiety, and even depression, so they've got strategies in place to ensure that they stay mentally sharp, even when things get tough. And then, there's the reality of life support systems. These aren't just about keeping the air breathable and the water clean. They're designed to keep the crew alive and healthy for years in space. The ship's systems constantly recycle air, water, and waste. Any malfunction could be disastrous, so the crew spends a lot of time monitoring and maintaining these systems. Even the slightest issue can have big consequences, so they stay on top of it every single day. Now, let's talk about the food. You might think deep space is all about freeze-dried meals and protein bars, but that's not the case anymore. The crew's meals are designed to be nutritious, easy to store, and easy to prepare, but they're also a bit of a morale booster. The ship has advanced hydroponic systems that grow fresh vegetables, and there's even a small greenhouse on board where they can grow fruits and herbs to spice up their meals. You'd be surprised how much the little things, like having a fresh salad on a long journey, can lift someone's spirits. Of course, all this tech is great, but even with the most advanced systems, things can still go wrong. And when you're out here, far from help, there's no going to the nearest repair shop. It's all about the crew's ability to fix things on the fly. The engineers on board are experts at troubleshooting, but even then, problems can arise that they've never encountered before. That's where the crew's adaptability comes in. They're constantly learning, evolving, and figuring out solutions to problems that no one could have predicted. So, while the mission to the binary star system is incredibly exciting, it's not without its risks. The crew faces challenges every day, whether it's cosmic radiation, mechanical failures, or the mental strain of deep space travel. But these are the challenges that come with exploring the unknown. And it's those very challenges that will shape this mission and the future of human space exploration. Okay, so here we are, folks. We're approaching our destination, the binary star system. We've been traveling for years now, and the end is finally in sight. It's hard to believe, right? After all this time, the binary stars we've been studying from afar are now right there in front of us. It's like a dream come true, but also, it's kind of surreal. The first thing that hits you when you approach a binary system is just how beautiful it is. Two stars, orbiting each other, lighting up the sky in ways you've never seen before. The light play alone is mesmerizing. One star could be a little brighter than the other, giving the whole system an eerie, dynamic glow. But it's not just the stars themselves, it's everything around them. The whole gravitational dance. The planets orbiting them, the dust and gas clouds hanging between them. It's an entire ecosystem of cosmic activity, and we're right in the middle of it. But it's not just about the beauty. We're here for a reason, to study these stars and their planets, and to figure out if any of these planets could support life. And there's a lot at stake here. A binary star system is different from a single star system like ours. The two stars orbit each other, and their combined gravity creates all kinds of unique conditions. These gravitational forces can affect the planets in ways we don't see around our own sun. For one, the planets in this system are subjected to a more complex pattern of solar radiation. The energy they receive isn't just coming from one star, but from two. And that can make for some very strange climates. Some planets might get blasted with radiation in unpredictable cycles, while others might experience periods of total darkness depending on their position in relation to the stars. That means, when it comes to potential life on these planets, everything we know about habitability is up for challenge. One of the big challenges here is studying the atmosphere of these planets. See, the combined light from two stars makes things a bit tricky when you're trying to get clear readings. You can't just point a telescope at a planet and expect to get perfect data. There's interference from the two stars, and sometimes it makes the atmosphere look different than it actually is. But that's why we've got our best scientists on board, equipped with the latest tech, trying to peel back these layers of mystery. And speaking of data, we're also dealing with the challenge of interpreting all of it. These planets are far from Earth, and the conditions are unlike anything we've encountered before. So the crew is constantly analyzing the data from all angles, looking for signs of water, oxygen, and other key elements that could indicate life. But it's not as simple as finding a planet that has water. There are so many variables, from atmospheric pressure to chemical composition, that could make a planet completely inhospitable. Now, here's the real kicker. Not all of the planets we're scanning are in a Goldilocks zone. That's the sweet spot around a star where conditions might be just right for life. In a binary system, this zone is constantly shifting. Depending on the position of the stars, a planet might swing in and out of the habitable zone, getting too hot or too cold depending on its orbit. Some planets might experience a sudden burst of heat, while others are plunged into a permanent freeze. But that's what makes this journey so exciting. We're on the cutting edge of scientific discovery here. These planets have never been studied this closely before. The data we're collecting right now could rewrite everything we thought we knew about how planets form, how stars interact, and maybe even how life begins. And that's exactly why we're here, to unlock the mysteries of this system and see what it has to offer. One of the planets that's caught our attention is orbiting the smaller of the two stars. It's rocky, and it's sitting just within the zone where life might be possible, but just barely. The scientists are particularly interested in its atmosphere, and they've been running multiple tests. The idea is to figure out if the conditions here are conducive to life, or if we're looking at a lifeless world that's simply too extreme. But of course, We can't just assume everything will go according to plan. This planet is in a unique position where the gravitational pull from both stars could create tidal forces that might affect its surface. In fact, the surface could be much more volatile than we first thought. Earthquakes, volcanic eruptions, and shifting tectonic plates might be a regular occurrence here. The crew is keeping a close eye on those readings too, just to make sure we're prepared for anything that comes up. As we get closer to our first real planetary scan, the anticipation on board is palpable. The crew knows this is the moment they've been working for. We've come all this way, and we're about to get the first real look at whether life is possible here, or if it's a planet that will remain a mystery, untouched by life, and maybe forever out of reach. We've made it. After years of travel, we're finally here, circling one of the most fascinating planets we've ever encountered. The surface is chaotic, with volcanic eruptions and storms that rage like nothing we've ever seen. But there's something else too, something even more mind-blowing. As we dive deeper into the data, we're starting to see signs that this planet might not be as dead as we once thought. At first, we thought this planet was a lost cause. It's volatile, unpredictable, and the chances of finding anything remotely resembling life seemed slim. But as we gathered more data, something strange started to happen. We picked up odd signals coming from the planet's atmosphere. At first, we thought it was interference, maybe from the two stars, or even from some nearby cosmic event. But then the signals began to repeat, almost like a pattern. Now, this is huge. What we're looking at could be the first signs of alien life. It's too early to say for sure, but the patterns we're seeing don't match anything natural. At least, not anything we know. Some experts think it might be a form of communication. Maybe it's from some kind of microbe or even a more advanced organism. Whatever it is, it's a breakthrough. The first hint that life might be out there, just waiting to be discovered. Now, before you get too excited, let me say this. We're still in the early stages of analyzing this. It could take years to fully understand what we're dealing with. But even so, this discovery has completely changed the game. If this planet is harboring some form of life, even if it's microbial, it could tell us so much about how life spreads through the universe. Still, we can't just stop here. There's more to explore, more planets to study, and more data to collect. We've got a long road ahead of us. The binary star system isn't just a destination, it's a new frontier. And it's a place full of questions that we still need to answer. As we head deeper into the system, we're keeping our eyes peeled for other planets that could hold similar mysteries. We've already learned so much from this one planet, but there's always more to discover. Every planet is a new puzzle, and each one brings us closer to understanding how life works in the universe, and maybe how we might one day live beyond Earth. But it's not just about the science. This journey is about something bigger. It's about humanity's future. We've spent centuries staring up at the stars, wondering if we're alone in the universe. And now, we're not just wondering, we're out here, searching, exploring, and learning. This is the beginning of humanity's next chapter. We're not confined to Earth anymore. We're building the future, one discovery at a time. As we push further into the unknown, we're not just making history, we're creating the foundation for the future of space exploration. We're laying the groundwork for future generations to explore even farther, to go beyond the stars we've already mapped, and to answer questions that we can only begin to imagine now. And the best part? This is just the beginning. What we're learning now will influence everything that comes after. The technology we build, the way we think about space travel, and maybe even the way we live. The discoveries we make in this binary system could lead to new advancements that help us survive in space, or even make it possible for us to settle on new planets one day. The journey isn't over. it's just beginning. As we look ahead, the possibilities are endless. What will we discover next? How will we change the course of human history? No one knows for sure, but one thing's certain. We're on the edge of something incredible. And as we journey into the unknown, we'll continue to learn, adapt, and explore, pushing the boundaries of what we know, and maybe, just maybe, finding the answers to some of the biggest questions of all.